Yeah, welcome back guys to another YouTube video. In this video, as you can see right here, we'll be talking about how to implement a linked list in JavaScript. It's going to be a great tutorial for beginners. If you don't know anything about linked list or you've been a little bit confused about it, I made this tutorial just for you to make you understand it fully. And the way this video is going to be structured is we're going to talk about what linked lists are, and then we'll talk about their disadvantages, their advantages, and also how to implement them. I will also create some methods to actually make our linked list more fun and actually play with the data more. If you're new to this channel, my name is Sam and I do tutorials like this weekly. And you know what? Let's get to the video. Now, what is a linked list? A linked list is a linear data structure similar to an array. However, unlike arrays, elements are not stored in a particular memory location or index. Rather, each element is a separate object that contains a pointer or a link to the next object in that list. Each element, commonly called nodes, contains two items, the data stored and a link to the next node. The data can be any valid data type. Now we can see a linked list right here. This is a nice illustration of it. The entry point to a linked list is called the head. The head is a reference to the first node in the linked list. The last node on the list points to null. If a list is empty, the head is a null reference. Nodes can easily be removed or added from a linked list without reorganizing the entire data structure. This is one advantage it has over arrays. Now let's talk about the disadvantage of linked lists. Search operations are slow in linked lists. Unlike arrays, random access of data element is not allowed. Nodes are accessed sequentially starting from the first node. Another disadvantage is that it uses more memory than arrays because of the storage of the pointers. Implementing a list node in JavaScript. I'm going to put a comment here and I'll just say construct single node. The way we're going to construct the single node is we use the class keyword. After that, we'll call our node list node. And you can call yours whatever you want. After that, we'll use the constructor keyword. And inside that, we'll give it an input of data. And after this, we'll use the this keyword to say this.data is equal to data. And now this. After that, we'll say this dot next is equal to null. So right here, we've created our constructor, our single node. Implementing a list node in JavaScript. The code shows the implementation of a linked list class with a constructor. Notice that if the head node is not passed, the head is initialized to null. Let's put it all together. The next we'll have our class again. And now we're going to call this linked list. And I'm just going to go right here and make this small letter because I want to use camel notation. But you can use whatever you want. It's just my preference. Actually, I should have done that here. So you know what? I'll change it again. Just use capital. Who cares? And after that, we'll use the constructor again. And now we'll set it to, we'll set the head equal to null. And we'll say this dot head is equal to head. Let's create a linked list with the class we just created. First, we'll create two list nodes, node 1 and node 2, and a pointer from node 1 to node 2. And we'll do that, we'll say let node 1 equal to new. We have to use the new keyword when we're adding a new node. We'll say new list node. And then inside here, I'll put 5. And I'm just going to copy this and change. And this is going to be node 2 is equal to 15. The next is gonna be node 3 is equal to 26. Node 4, we're gonna have 5 is equal to, its value is not, it's equal to new list node, and the value is gonna be, yeah, let's say 50. I will do the same thing. This is gonna be node 5, and here is gonna be 100. Now we've created a list. The next thing we need to do is we need to create the pointers that are going to point to the next nodes. And the way we do that is we'll say node 1 dot next is equal to node 2. And then we say node 2 dot next is equal to node 3, because this is how a linked list works. This is actually the implementation. This is how it's gonna show the next nodes. Now we say node 3 dot next is equal to node 4. Node 4 dot next is equal to node 5. And we know 5 is gonna be straight to null. So now that we have this, now what we need to do is we need to create a linked list with node 1. So we say let list equal to new, and then we say linked list. Inside it we'll put node 1. Now if we console.log, I will say list list.head dot next dot data. So that's how we're going to console.log 5. Now this way is how we're going to console.log 15. So this is the second node. How do we get the first node? The first node, there's no next, it's just list, head, and data. And we get 5. The second one is next, then data. The third is next and data. So you can see that the third we have 2 next because we have the head.data is 5, then 2 next, and then we get 26. And this is how we do it till we get now with 50, and the last one 100. And if we add another one, we should get an error. You see, can't read property data of null. Next up, we'll implement 4 helper functions for the linked list, and they are size, clear, get last, and get first. And from their names, you should kind of understand what they're gonna do, but I'll still explain them. The next thing, since we're creating methods, they have to be inside here. And the first method we're creating is size. To know the size of our linked list, I will set a variable called count, set it to 0. Then we'll say let node equal this dot head, and then we'll use a while loop to iterate through node, and we update our count, or you can call it counter, and then we say node is equal to node.next. After this, what we're going to do is we're going to return count, and I'm going to change this to counter, prefer counter. Yep, so we'll say right here, and now I can console.log list dot size. I can see we got 5, and it's actually 5 because 1, 2, 3, 4, 5. So it's very correct, and that is all about size, very clear and nothing too complicated. The next method we're creating is clear, and what this method does is that it empties out the list, and it's very basic. We just say clear, and it says this the head is equal to null. So now if I add clear here, so I say list dot clear, save it, you can see our size drops to 0, so it's no more 5. So this does the job. If I remove it, it's back to 5. So we can see our clear method actually works. And yeah, we will be releasing soon an object-oriented programming tutorial, a crash course on it. So yeah, keep your heads up for that. If you're new to the channel, guys, subscribe, like the vid. Shameless plug out the way. Let's continue. Now the other method I'm going to create is I'm going to create a get last. And that's another benefit of, as we talked about earlier, another benefit of linked lists is that it's easier to get elements in the beginning or the end, but it's much more harder to get elements between the beginning and the end. That's why arrays are better. If you need to do something where you need to get the elements between the first and the last, it's better you use an array. But if you're doing a project, or if you're solving a question, or you need something to happen where you need to store some data in the memory, and the memory you're gonna only need the first and the last, a linked list is very good for that. So we'll say get last, and say let last node equal to this in the head, and now we'll say if last node, and we'll say while, there's our while loop, we'll say last node dot next. Okay, let's take here. Let's say last node is equal to last node dot next. So this is the way we're gonna get our last node. Then we just return the last node. So we're basically iterating through the whole list, and then when we get to a stage where it's last node, and how we'll know it's last node is that the last node is going to equal next. So we return last node. And now we save that, and here our last node is 100. So if I console.log list dot get last, you can see right here we get 100. So it works perfectly. This method returns the first node of the linked list, and to do that we just write get first, and then just a simple return this dot head, and come back here, paste it, instead of last change that to first, save it, and now you can see we get 5. And just to cross check, I can change this to 66, and we get 66. And just to cross check, I can change this to And just to cross check, I can change this to 88. And you can see here we get 88. This is our first. So the next part, we're going to actually insert some stuff. The next tutorial, the part 2 of this tutorial, we're going to insert some more elements into our linked list. But for now, I think this is nice. This is a nice beginner's tutorial on linked list. Let's talk about the types of linked lists. Single linked list. Each node contains only one pointer to the next node. This is what we've been talking about so far. Now we also have a doubly linked list. Each node contains two pointers, a pointer to the next node and a pointer to the previous node. Circular linked lists are a variation of a linked list in which the last node points to the first node of any other node before it, thereby forming a loop. In this tutorial, we discuss what a linked list is and how it can be implemented in JavaScript. We also discuss the different types of linked lists as well as their overall advantages and disadvantages. I really hope you enjoyed it, and if you enjoyed it, please leave a like, subscribe to the channel please if you're new. I know what I'm going to wrap this up, and I'll see you in the next YouTube video.